Good day, people. Good day. Makadi Linjani. How are you? So here we are looking at engineering science, which is more like physics, right? These are physics concepts under the topic of Newtonian mechanics. What we are looking at is a question from engineering science, N4 engineering science. All right. Now, these concepts can also be found in grade 12 physical science, A-level mathematics, the mechanics section, physics A-level, or Cambridge, ZIMSEC, Oxford, whatever syllabus you'll be doing, as long as it is advanced level, you get these types of questions. But this one is for N4 engineering. Of course, in engineering, they will go on further to differentiate these things and, do a lot more. But this type of question, you can expect it at grade 12, at A level. All right, so this is a question we are doing today. Define Newton's second law. You must know there are 3 laws of Newton. First law, second law, third law. In any syllabus, a question usually starts by asking 1 or 2 or all of Newton's laws. And look, this is 2 marks. These are easy marks to get. So define Newton's law. The acceleration of an object is directly proportional to the force applied and inversely proportional to the mass of the object. F A is equal to F over M. All right. So if you increase the force, you increase the acceleration. If you increase the mass of an object, you are decreasing the acceleration. All right. It's easier to speed up a small car with 1 force than to increase the speed of a truck with the same force. So that is the consequence of this law. So that's where we get F is equal to ma. Force is equal to mass times acceleration, a very common formula. So you can use a formula to define Newton's second law. This formula or that formula, or give it in words, but you must know how to interpret it in words. So this is what it states. All right. Let's go on to the second question. A motor car with a mass of 850 kgs accelerates uniformly from rest up a gradient of 1 in 40 and reaches a speed of 60 kilometers per hour after 1 minute. Upon seeing this question, the first thing you must look for is units. Usually we don't use kilometers per hour and minutes. We don't use them at all in physics. All right. So you must convert to meters per second, seconds. So first thing I would do, but the mass is okay. It's at 850 kgs. This is all right. So M, 850 kgs. U, initial, accelerates from rest. So U, which is our initial velocity, will be 0 since we are starting from rest, and V is equal to 60 kilometers per hour into meters per second. We say 60 kilometers means 1,000, isn't it? 1,000 over 1 hour, which is 3,600 seconds. So this should give us 16.67 meters per second. Because we have to convert to standard units. Okay, standard units that we use. 1 minute time. 1 minute is 1 times 60. So there are 60 seconds in a minute, which is equal to 60 seconds. So we'll be using these quantities. All right. They are now standardized. Calculate the following. Acceleration of the motor car. So what we should know are the equations of motion. V is equal to U plus AT, S is equal to UT plus half AT squared, and so forth. So we must know these. What is the formula to use with what we are given? V is equal to U plus AT. We are given time. We are given initial speed, final speed. So we can calculate the acceleration. So we can say V is equal to U plus AT. And when we rearrange this equation, A is equal to V minus U over T, which is 16 minus 0 over 60. What would that give after we substitute our values? This will be 0.28 meters per second squared. Okay. We must know units. Usually students forget to put the units, and these carry to a mark. So when you are given a question like this, acceleration of the motor car, and you are given 2 marks, know that 1 mark is going to the units or the answer as a whole, and then the working will get 1 mark. So always look out for mark allocation when you are answering a question. That should guide you on the amount of work that you should put in. Okay. Kinetic energy that the motor car possesses at the end of 4 minutes. All right. So we might want to know, because EK is equal to half mv squared. We have the mass, but we have the velocity, final velocity, after 4 minutes. All right. So again, using V is equal to U plus AT. We now have the acceleration. We want to find the velocity, the initial velocity, which is 0, 0 plus acceleration, 0.28 times time, 4 minutes. Okay? Which is 4 times 60. Remember, we must change minutes to seconds. All right. So this will give us 0.28 times 4 times 60, which is 67.2 meters per second. That is the speed after 4 minutes. Remember, this thing is accelerating. The passing of each second, the speed is increasing. So we expect the speed to be greater than the initial final, which is 0, or after 1 minute. Right, so we have 67.2 meters per second. Now we can calculate our kinetic energy. We have said kinetic energy is half mv squared, which is half times 850 times 67.2 squared, which will give us 1,919,232. And remember, the unit for energy is joules. we can present it as 1.92 mega, meaning million joules. So we must know kilo, mega, our giga, our, these multipliers. Okay, this meaning times 10 to the 3, times 10 to the 6, times 10 to the 9, and also milli, micro, nano, all these multipliers by 10. All right, you must know that. Okay, so that is the energy that we have, 1.92 megajoules. Then we go on, gain in potential energy. Okay, so now we have to look at our diagram. What are we, how does it look? In order to calculate potential energy, we need to know the height reached, because potential energy is mgh. We are given a gradient there, and we have to have a diagram. Let's look at our diagram and look at the marks, 6 marks. So this is quite some work. Okay, our gradient is 1 in 40, which means 1 in 40. Because if we say 1 in 40, which means 1 is to 40, which means our y there, our x there. So our y is 1, our x is 40. All right, we have an angle there, angle of elevation, or angle of incline from the horizontal. All right, so we have 1 in 40, and we might want to know our hypotenuse. Okay, so we say this is a right angle triangle. So we say, in order to get our h squared is equal to 40 squared plus 1 squared. We are applying Pythagoras theorem to get, the aim is to get ratios so that we can find the sine, the tan, the cos. Okay, so h squared is equal to 40 squared plus 1 squared. H is equal to h is equal to square root of 1601, because 40 squared is 1600, 1 squared is 1. If we add them, we get 1601. So this is root of 1601. Okay, so now we can, let me clear some space here. We can now know the ratios. We know already that tan theta, which is tan of this angle, is equal to 1 over 40. Use your Chashotao or your SOHCAHTOA, which one you are familiar with, to find the tan of that angle. The cos theta is equal to adjacent, cos adjacent of hypotenuse, which is 40 over root 1601, and sine theta is equal to 1 over root 1601. Right. So we might use one of these to find the height. All right. Now we have the trig ratios of the sides. What do we want to do? gaining potential energy. So from this, from the kinetic energy after 4 minutes, we can find the distance traveled. All right. So let's have a diagram just to give us a visual of what is happening. Diagrams are very important. So we are saying this body is moving from here to there. Okay. U is equal to 0 meters per second. V, final velocity after 4 minutes, we have found that it's 67.2 meters per second. And the time it has taken is 4 minutes, which is 4 times 60, which is 240 seconds. So we might want to find the distance covered. Okay. So which formula from these do we use? S is equal to UT plus half AT squared can work, right? Because we have U, we have A, and we have T. Okay, so now we can say S is equal to UT plus a half AT squared, which is 0 times 240 plus half. Our acceleration is 0.28 times 0.28 times 67.2 squared. All right. No, our time is 240. 240 squared. Okay. So what do we find? Our distance covered is 8,064 meters. So we've covered the distance of 8,064 meters. So we have this situation where we have 8,064 meters. We have an angle of theta, okay? And we want to find this height, because to find potential energy, we must say mg times h. We have the mass. We know the acceleration due to gravity is a constant. We need to find the height. We have found the distance traveled up the incline. And we know the trig ratio there. All right. So we have opposite and hypotenuse. When you are doing opposite and hypotenuse, it's sine. Okay, sine is equal to opposite of hypotenuse, or sine is equal to opposite of hypotenuse, whichever you are familiar with. Okay, sine theta is equal to opposite over hypotenuse. What is sine theta? 1 over root 601. 1 over root 1601 is equal to opposite is what we are looking for, which is the height. Let's just put h now. H over hypotenuse 8064, which is this distance. So our h, which is our height, will become 8064 over root 1601, which is what? Our height will be 201. So if you punch this on the calculator, you get 201.54 meters. Okay, this is a height. Now we know this motion up there in 4 minutes has brought it to a height of 201 point what? 54 meters. All right. Now we can calculate potential energy, which is gravitational potential energy. Our mass is 850 from the question, 850 kgs times acceleration due to gravity, 9.81 times our height, which is 201.54. Now this will give us a energy of 1,608,517 joules, which we can say is equal to 1.61 megajoules. All right. So this is the 6-mark question. Look at the work we have done so far. So that is how you answer these questions. All right, inclined planes. I must know if you are doing mechanics in either grade 12 physical science, advanced level Cambridge or ZIMSEC, and if you are doing engineering subject, especially electrical engineering, mechanical engineering, civil engineering, and things like that. So this question came in the South African syllabus of the N4 engineering science, N4 engineering science, which we also teach and direct at one-on-one maths private tutors. We are based in Cape Town. The numbers you can find on the on this post. All right, so get in touch with us. Let us help you achieve your goals. Thank you, people. Thank you very much.